Imagine a scenario where two randomly generated particles are shot out of a source at the same time. There are two detectors on both sides equidistant apart from the source that measure the particle's projections either on the x, y, or z axes. If the detectors are set to measure the same axis, the particle's randomly generated projections on the selected axis are always opposites, 100% of the time. These particles are said to be in an entangled state because they seem to be communicating with one another. Einstein called this communication spooky action at a distance. Einstein believed in an objective reality as the root of all science. A particle's reality isn't dependent on any other particle or measurement. It's independent. The particle has its own reality. Each individual particle has its own instruction set, or hidden variable, that tells the particle how to act when measured. This possibility will later be ruled out in the video. Einstein didn't like the actions of entangled particles because the reality of one particle seemed to be dependent on the other. In the famous EPR paper written by Einstein, Podolsky, and Rosen, the authors criticized quantum mechanics, saying it allows for the reality of two independent particles to be dependent upon the process of measurement carried out on the first, and no reasonable definition of reality could be expected to permit this.
Although EPR was widely accepted by scientists for a time, John Bell came up with an experiment to test the idea of the hidden variables. Now, how it would work would that there would be two spin detectors set up, and each detector is capable of measuring spin in one of three directions, and these directions would be picked in a random and independent way of each other. And there would be pairs of entangled particles will be sent through the detectors to measure the spin. Now, for EPR to work, the hidden variables can be thought of as a sort of plan between the two particles. And before the detection, the particles would communicate with each other to give opposite spins in any given direction. So for example, there would be one plan for one particle to give a spin up in any direction, and by default, the other particle would give a spin down in any direction. Now this would be done over and over with different plans. And the results came in, and the plan with the least amount of different results was one with a 5/9 certainty of opposite spins. And overall, if the particles do contain hidden variables, you should see different results more than 5/9 of the time. Now, in reality, this is different because the results are only different 50% of the time. So this experiment rules out that particles contain hidden variables about which spin they will give in the different directions. Yeah, whenever you guys are ready.
So one of the ways to test non-locality is the Bell test. Einstein didn't really like this test, and here's why. In the Bell test, they'll either use one of two kinds of particles. You'll use an electron, and in this case, you have two electrons, but in order to keep them entangled, we couldn't get them far enough apart while keeping them entangled to really prove that the information traveling between them was faster than the speed of light. Also, you had a photon, but photons are really hard to detect, and we didn't really know if there was any information missing, like Einstein proposed a hidden variable that we're just not accounting for. But then someone had the bright idea of, why not both?
¿Por qué no los dos?
So, recently, this was after Einstein's time, they decided to have an electron that was in a superposition and entangle it with a photon, bring that photon to another photon, and then have that photon interact with another electron also in a superposition. Now you have two entangled electrons. Also, these electrons are about 1 kilometer apart. That's like interacting with your friend that's on the other side of the galaxy. in relative to the size of the electrons. And the distance was fixed the problem of, yeah, they're far enough apart to where you could have the information traveling faster than the speed of light, and they are still entangled. So they did, as we mentioned before, they measured this one electron as orientation up, and then they also got that this is orientation down, thus proving non-locality. Hi, I'm Matt. Welcome to Quantum Jackass. Right now, I'm entangled with that guy and he has no idea. So when I pick either up or down, he's gonna have to do the opposite. All right, so check this out.